In this lab, our main interest is to examine if the quantitative test scores and study hours predict the stat test scores. So let's read the scenario for a second. In this lab, the researchers, want to examine whether quant scores and study hours predict the statistic test scores. So simply here, what is the predictors? What are predictors? Yes, this is predictor one, independent variable, or predictors one, and the study hour is a independent variable two, and what is the dependent variable or outcomes? The statistics test score is our dependent variable or outcome. And then we want to know how well the model can predict the statistics test scores by comparing the observed scores and the expected scores by the model. So this later part is about the model fit. So once we fit the model using two independent variables and then one dependent variables, we want to evaluate the model fit later on. So let's keep move on. So the first questions show if the pairs of the three variables tend to show linear relationships. So first, at the first, we want to figure out overall trends in our data before precisely testing it. The best way to figure out the overall trend is plotting. In this scenario, the variables that we handle are categorical or continuous. Yes, it's a categorical variable. So all those are continuous variable. Therefore, we'd like to depict linear associations among the continuous variable, and a scatter plot with the fit line should be the easiest and explicit way to show those linear associations. So we're gonna draw the scatter plot. So we have two predictors and one outcomes. We're gonna separately draw the scatter plot for the two predictors with one outcomes. So the first one, we're gonna plot the quant test scores and then statistics test scores. And the second questions, we're gonna plot study hours and then statistics test scores. And then the last one, actually, we're gonna plot all together in one matrix. So we're gonna get there later. So first, we already went through this multiple times. So go to graph, go to chart builder, and then go to scatter plot. And then the first one is a simple scatter plot. Just simply drag to the chart preview. And so let's move quantitative test scores to the x-axis. And then let's move the statistics test scores to the y-axis. And then click the OK. And you got the graph, the scatter plots on your output file. And then double click it. And then go to the add fit line at total. Click it. Then you could see the fit line on your scatter plot. And simply close it, and still you can see those fit lines on your scatter plot. So over here, can you see any kind of linear trend in the data points? Obviously, yeah, it's not the exact one straight line, though. Still, we kind of see there's a trend. There's some linear trend in your data points, and then once you put the fit line, that fit line really helps us to see the linear trend a little bit more explicitly, and then we could see the fit line. We could see the linear trend over here. However, I'm saying trend. the data points tend to show the trend of a linear relationship. By the trend or by trend, I meant that this is not like significant test. There is no statistically significant linear relationship or not, because this is just visualized examinations. It does not tell anything about the statistical test. However, still we can see there's some trend. So let's go up a little bit more. They tend to show a linear relationship. Therefore, it is appropriate to conduct a linear regression analysis, because if it is not linear, that means we actually cannot apply linear relationships, and it is not really meaningful to fit the linear regression model, because, for instance, if there is a no relationships like this, do you think it's really meaningful to fit or to say like X predict Y? Because obviously the visual examinations shows us that there's no quite systemic relationship between X and Y. That means it's not useful or meaningful. We actually don't need to fit, because obviously there is no systemic relationships. So this is why we usually draw the plot first to see the overall trend in our data. And then the second one, let's go to the SPS output and then just repeat the same things, and then with the different x-axis. Just move to the study hours to the x-axis. Okay, sorry, I made a mistake. So not time of class, study hours. Yeah, study hours should go there. So the same way, oops, I clicked the wrong one. So, okay. Then you could see another one, and then in the same way, you can put the fit line on it. And then next, we're gonna actually show all those pairs, the relationship of all those pairs in one big matrix. So we could see all those relationships in one big pictures. So go to graph and go to chart builder, and then instead of the simple scatter plot, what we just did it was using simple scatter plot. Instead of that, we're gonna use scatter plot matrix. So drag it to the chart preview, and there is only one kind of axis. So let's move all stat, quant, study hours, three variables of the interest. Let's move all three variables to that axis. And then click OK. So what you're going to get is this big matrix. And then I'm going to explain how to interpret this matrix. So I'm going to take this out. Let's move to here. Okay, the last question, draw and paste a matrix scatter plot of the relationship between all pairs. And then we actually could see the overall patterns in here. So this is statistic test scores. And then this is a study hours. So this one, the x-axis is statistic test scores, y-axis is study hours, and this one, x-axis is a statistic test scores, and y-axis is a quantitative test scores, and then this one, stat and stat. Okay, obviously there isn't nothing, right? Because it's the same variable. And then this is a quantitative test score. This is a study hours. This is quantitative test scores, and then this is a statistic test